Welcome back, everybody. Continuing our chapter on triangles today, we're talking about isosceles and equilateral triangles. Now, the theorems we're going to give you about isosceles and equilateral triangles are going to build right off the triangle congruent stuff we've been doing the last few sections. Okay, so like always with geometry, kind of each new result we come up with builds and leads to more results. Okay, so let's get going with isosceles and equilateral triangles. So first things first, let's make sure we define what an isosceles triangle is. Now that's a definition you have seen before, something you should know. An isosceles triangle is just a triangle with two congruent sides. Okay, now typically we call those congruent sides the legs. And then a few other definitions we'll use a little bit. We'll call the non-legs, okay, the non-congruent side, the base of the triangle. We'll say that the angles that attach the legs to the base will be the base angles, and the third angle will be the vertex angle. Okay, the big thing is the legs and base angle, kind of the angles across from the congruent legs, will be the ones we talk about moving forward. And then we'll give you our isosceles triangle theorem. It just says that if two sides of a triangle are congruent, so in other words, if we have an isosceles triangle, then the angles opposite of those sides are congruent. Okay, so in other words, if we have our legs of an isosceles triangle congruent, the base angles across from them will also be congruent. Now, we can also give you the converse of this theorem, which comes along with the exact same picture. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So in other words, if we have two congruent angles in a triangle, then we do have an isosceles triangle. We will have those congruent legs. And then last theorem we have for you quick, this is one of those nice to know, not need to know, but nice to know theorems. It just says that if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. Okay, so in other words, if we have our legs and our vertex angle between the legs, and we have a line that bisects it, splits it directly in half, it's also going to be the perpendicular bisector of the base. So it's going to hit at a right angle for perpendicular, and bisect, it's going to split that base into two congruent parts. All right, so let's put those theorems to work. Problem one, it looks like we have a couple of triangles, a couple isosceles triangles, and what we want to work on doing here is matching up the congruent parts and seeing how they relate, how the different sides and angles relate to each other. So part A says, is segment AB congruent to segment CB? Explain. Let's take a look here. We have AB on the left, and we have CB on the right. Okay, we want to know, are they congruent? Well, I'm going to say yes, okay, because notice for this longer triangle, this larger triangle, CB is across from angle A. AB is across from angle C, and since angles A and C are congruent, I know the sides across from them will be congruent as well. Okay, so we look at these entire sides, we can say yes, those will be congruent to each other. Okay, part B asks, is angle A congruent to angle ADE? All right, so we have angle A here. And angle ADE will be this one right here. Now, as far as are they congruent to each other, we don't know. I do know that angle A and angle DEA will be congruent. Okay, because they're both across from congruent sides. So this is an isosceles triangle. We know the base angles will be congruent. But I don't necessarily know how angle ADE relates. Okay, so will they be congruent? I'm going to say IDK. I suppose technically they could be, but we're not given enough information in this problem to figure that out. Okay, problem B is the same idea. There'll be two yes or no questions. Why don't you take a minute, pause the video, work through A and B, and then hit play to check your answer. All right, so let's run through C and D. C asks, is TR congruent to TS? Explain. All right, TR is right here, and TS is right here on the left and right side. And for this one, I'm going to say right off the bat, IDK, I don't know. Okay, because I'm not given that they're marked congruent, and then also I don't know if angles R and S are congruent to each other at this point. Okay, we'll actually figure that out in the next part of the question. So for now, I'm just going to say, I don't know if these two sides are congruent. Okay, let's look at the second question. Is angle S congruent to angle WVS? Explain. Okay, so we have angle S again, and WVS is right here, so here's our two angles we're talking about. Now, since they are both across from congruent sides of an isosceles triangle, we know, yes, they will be congruent to each other. So for this one, we can say right off the bat, yes. But then also, notice in the first one, we talked about angle S as well. So I can actually get rid of this IDK and say yes for this one as well at this point. Okay, since angles R and S are not congruent, they both have one arch on them, we know that the sides they're across from will be congruent as well. All right, next up, let's take a look at some problems where we solve for angles on isosceles triangles. Problem 2, pretty straightforward. What's the value of x? Looks like I have an isosceles triangle. I know one of the angles, and I want to use that to figure out this x here. Now, typically when we're solving for angles of triangles, we need to know 2 out of the 3 to solve for the third. But with my isosceles triangles, since I know that the base angles will be congruent, essentially what I can do is I can think of both of these angles as having a measure of x. And then I can set up a simple equation to solve for that x. So we can say that x plus 30 is equal to 180. So in other words, 2x plus 30 is equal to 180. Subtract 30 from both sides of this equation and end up with 2x is equal to 150. And then to divide both sides by 2 and get x equals 75 degrees for this one. Okay, and again, the reason we're able to set up that equation is we knew these two base angles were the same since the side lengths of the isosceles triangle are the same. Okay, now you don't necessarily need the equation. If you want to think more algorithmically, I can just think 180 for the total minus 30 divided by 2 to split up kind of what's left across these two equal angles. Okay, so whether you do it algebraically or go straight to the calculator or somewhere in between, that's okay as long as you're getting the right answer. All right, problem B, same idea. We're dealing with isosceles triangles once again. This one's going to have a little more going on, a little trickier. Okay, the goal here today is going to be to show you a bunch of different ways these can work out so you can problem solve when you get to the homework. All right, so what's the value of x? Now, there's a couple ways we can do this. Either way, what we're going to do is we're going to use the fact that this larger triangle, when I combine the two, is isosceles. Since I have congruent legs, I'll also have congruent base angles. And I suppose I better put 2 arches on those to show that these two angles are not congruent to the two angles on the right at angle B here. And then from there, there's a few things I can do. One would be to use that angle bisector theorem, where if I look at just the smaller triangle, BCD, okay, since this segment BD bisects my vertex angle, angle B, I know it's going to be a perpendicular bisector and make a right angle with the base of this larger isosceles triangle. So what I can do with that then is I can solve for the missing angle, given the two angles I know. I can say that x plus 90 plus 54 is equal to 180. So in other words, x is going to be equal to 180 minus 90 minus 54. I want to check that quick. So we end up with x equals 36 degrees. Okay, so that'd be one way to get my answer. The other thing I can do is I could ignore this right triangle here and just look at this larger triangle. And as far as the angles go, I know that angle C is 54 degrees. I know angle A is 54 degrees. And then this larger B is going to be made up of two x's. So for that, what I could set up is x plus 54 plus 54 is equal to 180. So in other words, 2x plus 108 is equal to 180. And then same idea, if I subtract 108 from both sides, we'll end up with 2x is equal to 72. Divide both sides by 2, and we end up with x equals the same, 36 degrees. Okay, so as you can see, there's a few different ways we can get through that one. I'd say that that extra angle bisector theorem makes life a little bit easier. But again, it's nice to know. You don't need to know it. You could always do this as a whole larger triangle as well. All right, a couple more questions we can do. And again, we're trying to show you a bunch of different ways we can kind of apply those isosceles triangle theorems to different situations. Okay, next one we want to solve for x and y in this, again, isosceles triangle. And I suppose the difference this time is I have an exterior angle. So what I can do with that is I don't know any angles in my triangle, but since I have an exterior angle, I can start by finding an interior angle. We can use this linear pair here, which will add to 180 degrees. So if I go 180 minus 110, that's going to give me 70 degrees. And since these are both base angles of my triangle, the 70 and the y, I know they'll be congruent to each other. In other words, right off the bat, I know y equals 70 degrees. Okay, so I know two angles of my triangle now. To find the vertex angle, I can just subtract those. So we could say x is equal to 180 minus 70 minus 70. All right, in other words, x is equal to 40 degrees. Okay, hopefully you're seeing that these are similar to some of the triangle problems we did last chapter. We're just kind of adding that base angles are congruent of isosceles triangles piece to it. But otherwise, there's a lot of the same solving techniques we've been doing for a few chapters now. All right, we're going to do one more isosceles triangle problem that deals with side lengths this time. So for D, what is the value of x? And it looks like my x's are related to expressions for the side lengths. Now, I couldn't do this one if I didn't know these two angles were congruent. Okay, since they are, I know the sides across from them will be congruent as well. So what I can do then is I can just set these two sides equal to each other. We can just say that 7x minus 10 is equal to 3x plus 6. Okay, because those sides are equal, and I know that because my base angles are congruent as well. And then I can solve for x. I'm going to subtract 3x from both sides. That's going to give me a 4x minus 10 is equal to 6. Then going to add 10 to both sides. That'll give me a 4x equals 16. And finally divide both sides by 4. And we end up with x equals 4 for this one. All right, so pretty similar algebra to stuff we've done in the past. Again, the only new part is since I know that my base angles are congruent, my sides across from them, the legs of that isosceles triangle, will be congruent as well. All right, one more thing we're going to talk about today, and that's going to be a corollary to our isosceles triangle theorem. Now, what a corollary is just a theorem that can be proved easily using another theorem. So, for example, I'm going to talk about corollaries dealing with equilateral triangles, and we'd say they're corollaries because once I have my isosceles triangle theorem, they're just a result of that theorem. Okay, so we have two of those. The first one says that if a triangle is equilateral, so if all three sides are congruent, then the triangle is equiangular. In other words, all three angles are congruent. And we can also give you the converse of that. If a triangle is equiangular, so if all the angles are congruent, then we know it's also equilateral. Okay, I'm going to take this one step further actually, and I'm going to say that if we know a triangle is equilateral, we actually know what all those angles add up are equal to. Okay, if I take 180 for the total and divide it by 3, I get 60 degrees. So I know that all three angles of my equilateral triangle will always be 60 degrees. Okay, so we know a triangle is equilateral, we know its angles are all equal and all 60. All right, so let's put those corollaries to work here then. Problem 3, part A says find the values of m and n in this figure here. And here's the trick for that. Notice I have two triangles and one of them is equilateral. Therefore, I know that all three of its angles are 60 degrees like we just said. Meaning that this part of the right angle here is 60. So if I want to find angle n then, what I'll do is I'll just take 90 for the right angle minus 60, which is going to give me 30 degrees for n. All right, once I have that 30, I can focus on this smaller right triangle. And I know two of the angles already. I know the 30, I know the 90. So to find m then, we can just take 180 for the whole triangle, minus 90, minus 30, which will give us a 60 degrees as well. Okay, so again, some similar angle solving, some similar triangle angle solving to things we've done in the past. The only new part here, since I have an equilateral triangle, I know all three angles are congruent and all three angles are 60. Okay, part B is the same idea. Why don't you take a minute, pause the video, run through that one quickly, and then hit play to check your answer. All right, so let's run through part B quick. It says find the measure of angle ADC. Well, let's see what we're talking about here. A to D to C. So we're talking about this larger angle here made up of two parts of our two triangles. Okay, this one's actually pretty simple. The angle on the left I can get using my isosceles triangle theorem. There we go. Okay, since I have an isosceles triangle with two sides congruent, I know the angles will be congruent as well. So this angle on the right here, this ADB, will be 66 degrees. And then for the angle on the right, notice on the right I have an equilateral triangle. I know that all angles in an equilateral triangle are just 60 degrees. So the measure of my angle ADC then will be the 66 from the left plus the 60 from the right. In other words, 126 degrees for a total. Okay, great little question that combines both the equilateral triangle theorem, all angles of an equilateral triangle are congruent at 60 degrees, along with our isosceles triangle theorem, where base angles are congruent. All right, so that's it for our section on isosceles and equilateral triangles. Some new stuff we threw at you today, but hopefully you saw that a lot of it was similar to what we've been doing for a few chapters now. Okay, so start cranking out the homework, start going to town on that, and like usual, if you need help, we'll be here to help you out. We'll see you folks later.